So that's a good suggestion. Let's look at right here. We have a local maximum. This is a local maximum, but it's not a global maximum because the curve exceeds that value. So local versus global can be hard for people to recognize. Maximum versus minimum is rarely very challenging, but they're two common mistakes people make. So do y'all see why this is a local maximum but not a global maximum? So with a graph, it's not too bad. Now let's talk about what happens if you have a formula and you're given this. So let's forget for a second that we have a graph, and let's go over how we would try to find local maximum and minimum on a graph that has no endpoint, because the function here never ends. So for a function whose graph has no endpoints, or you could say for a function defined on what's called an open interval, the domain never stops. So the first thing we're going to do, we're not going to graph it because we're not doing that. Instead, the first thing we're going to do is find the critical. Step one, find the critical points. Now, in looking at this, we have x cubed minus 2.1x. Is my f of x. So the first thing in finding the critical points is I need to take the derivative. So I have f of x equals x cubed minus 2.1x. And so I have f prime of x is equal to 3x squared minus 2.1. So then I'm going to set this f derivative equal to 0 and also check and see, are there any places where it's undefined? But because this is a polynomial, not a big deal. So we need to solve f prime of x equal to 0. So I'm going to be solving 3x squared minus 2.1 equal to 0. Now, because this has, do I need the quadratic formula here or need to factor anything? Why not? Yeah, I only have one place the unknown appears in an x squared, so I can isolate that unknown. So we're going to do the algebra, not to belabor it too much, just to nicely explain. Thank you. Isolate that unknown, and I'm going to have 3x squared is equal to 2.1. So then I divide both sides by 3 to isolate this to a square root. Excellent. So then I'm going to have x squared is equal to 2.1 divided by 3. And so I know that the solution of x squared is equal to a positive number will be x is plus or minus the square root of 2.1 divided by 3. Now, the challenging part is that's finding the critical point. So that's step one. So now here's the next step. The next step is we're going to make what's called a sign chart. And the sign chart is going to be, we're going to divide the real numbers up according to these values. So we're making a sign chart, and I'm going to take my real number line, and I'm going to chop it up into pieces. In the first place I'm going to chop it, it's going to be at this negative square root of 2.1 divided by 3. And the next place I'm going to chop it is as at this positive square root of 2.1 divided by 3. So this divides the real numbers up into 3 intervals. I have the interval from negative infinity, negative square root of 2.1 over 3. I have the interval from negative square root of 2.1 over 3. I'm interested in what occurs between these points and not what actually happens right after. So that's a good point. We're using open instead of closed, even though we could technically touch the critical number. Now, the reason we're dividing it up this way is we want to know what's happening f in terms of whether it's increasing or decreasing. So if I'm looking at that, I want to know, is f prime positive or negative on this interval? And it won't be 0. I know it won't be 0 because I found all the places where it would be 0 already. Now I'm going to take this and I'm going to take it each place. I'm going to determine for each interval in between these points, is f prime positive, negative, or 0? All I need is one point to evaluate because f prime is not going to just randomly change signs except between critical points. So let's look at the interval on negative infinity, negative square root of 2.1 divided by 3. We need one point. We need one number that falls in that interval. So can you tell me one number that is between negative infinity and negative square root of 2.1 over 3? Negative 6 works great. So I'm looking at negative 6. I'm going to take my derivative, which is this, my f prime of x. Remember, we found it a second ago was 3x squared minus 2.1. If I plug in negative 6, I say f prime of negative 6 is equal to 3 times negative 6 squared minus 2.1. And all I care about is that number positive, negative, or zero? That's the result of this calculation. If I think about -6 squared, that becomes a pretty large positive number. If I multiply it by 3, it becomes even bigger. Subtracting off 2.1 doesn't do much to change that. So would you believe me without calculation, just by reasoning, that f prime of -6 is greater than 0? So what that tells me is that on this, f prime of x is positive. So f of x is increasing. Now we can do this one more time, and we can do it for an interval, or we can do it for a number in the interval that includes 0 here. So if I look at doing this calculation on this interval, I could pick 0. If I do that, then I have f prime of 0 is equal to 3 times 0 squared minus 2.1. It'd be -2.1. So what can I conclude about f of x based on this? So f of x is decreasing on the interval from negative square root of 2.1 divided by 3 to square root of 2.1 divided by 3. So I think about this. Okay, at this point, my function went from increasing before this number to decreasing after this number. So is that a local max or a local min? So I would have a local max at x equals negative square root of 2.1 divided by 3. It's a lot of thinking and reasoning, but it's worth doing because not only is it useful in situations where we can't graph very easily, but it reinforces a lot of things that we are looking at in terms of the derivative and how to interpret it.